In this video, we will learn how to solve numerical problems based on liquid pressure. Now, pressure is expressed in Pascal, and therefore we will need to look at certain important conversions before we start. Those conversions are centimeter square to meter square, centimeter cube to meter cube, kgf to Newton, and gram per centimeter cube to kilogram per meter cube. So let's look at the first one. 1 centimeter square is equal to 1 centimeter into 1 centimeter, and since 1 centimeter is equal to 10 raised to minus 2 meters, 1 centimeter square is equal to 10 raised to minus 4 meter square. Next, centimeter cube to meter cube. Now 1 centimeter cube is equal to 1 centimeter into 1 centimeter into 1 centimeter. Since 1 centimeter is equal to 10 raised to minus 2 meters, 1 centimeter cube would be equal to 10 raised to minus 6 meter cube. Kilogram force or kgf to Newton. Now the kilogram force is defined as the force of the Earth's gravity acting upon a mass of 1 kilogram. Now we know that the force of the Earth's gravity is equal to mass into acceleration due to gravity, and 1 kgf of the force of gravity would be equal to the mass, which is 1 kilogram, into the acceleration 9.8 meters per second square, and that is equal to 9.8 kilogram meter per second square. Since kilogram meter per second square is equal to Newton, 1 kgf would be equal to 9.8 Newton, which is approximately equal to 10 Newton. Now, gram per centimeter cube to kilogram per meter cube. Now 1 gram per centimeter cube can be written as 1 gram upon 1 centimeter cube. Now 1 gram is equal to 10 raised to minus 3 kilogram, and 1 centimeter cube is equal to 10 raised to minus 6 meter cube. So this will be equal to 10 raised to 3 kilogram per meter cube. So that means 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. So to summarize, 1 centimeter square is equal to 10 raised to minus 4 meter square, 1 centimeter cube is equal to 10 raised to minus 6 meter cube, 1 kgf is equal to 9.8 Newton, and 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. Now we will use these relationships in order to solve liquid pressure problems. So let's look at the first problem. A cylinder of mass 6 kg and cross sectional area 300 centimeter square is kept upon a table. Determine the thrust and pressure exerted by the cylinder upon the table. So here we have the mass as 6 kilogram, and the cross sectional area is equal to 0.03 meter cube. So the thrust exerted by the cylinder would be equal to the weight of the cylindrical block. So it will be 6 kgf, which is also equal to 60 Newton. The pressure would be equal to the thrust upon area, and by replacing the values of thrust and area, we get the pressure as 2000 Pascal. Let's look at another problem. A 48 centimeter liquid column exerts 8655.36 Pascal of pressure. If G is 9.8 meter per second square, determine the density of the liquid in CGS units. So here we have the height as 48 centimeter equal to 0.48 meter. The pressure is 8655.36 Pascal. The acceleration due to gravity is 9.8 meter per second square. So we use the formula P equals to h rho g. So this formula implies that the density rho would be equal to the pressure P divided by hg, and by replacing the values we get 1840 kilogram per meter cube. So here the density has been asked in CGS units, so we will multiply 1840 with 10 raised to minus 3. In other words, we are dividing 1840 by 1000, and we get the density in CGS units as 1.84 gram per centimeter cube. And another problem here, The pressure of water on the ground floor is 150 kilopascal, whereas the pressure on the fourth floor is 30 kilopascal. Calculate the height of the fourth floor. So let's understand the problem over here. Here is the building, and the water to each of these floors is provided by an overhead tank, and this overhead tank is at a height h4 above the fourth floor and at a height h0 above the ground floor. Height of the fourth floor would be equal to the difference between the liquid columns of the ground floor and the fourth floor, and that is h0 minus h4. So here we have been given the pressure on the fourth floor as 30,000 Pascal and the pressure on the ground floor as 150,000 Pascal. We've converted kilopascal to Pascal, and we have to find h0 minus h4. So h0 minus h4 would be equal to p0 divided by the density and the acceleration due to gravity minus p4 divided by the density and acceleration due to gravity. After simplification and after replacing the values, we get the height of the fourth floor as 12 meters. So that's all in this video. In the next video, we will learn Pascal's law and hydraulic machines.